this video, I'm going to use the CX300 to sweep a mobile antenna. First, I'll go to the grid and select our network analyzer. And I'm going to choose the VSWR. So now we'll do some configuration. We'll go to this menu bar, and I'm going to set this for a start and stop frequency. I'm going to set the start frequency for 100 megahertz, and I'm just going to sweep to 1 gigahertz. And I'm going to sweep for return loss, and I'm going to give it 460 data points. And that's pretty much all I got to do to configure this. So I'll close the menu. And with nothing connected, I've got a 0 dB return loss selection up here. I'm using the default cal factor, which is factory calibrated, and should be good. If a calibration is required, it comes with a short open load cal kit that can be used to recalibrate it. But right now, I'm going to connect my cable from my mobile 800 meg antenna to the RF output port on the CX300. And I can see the return loss across here. And I'm going to do something with markers. I'm going to select markers. And I'm going to set a horizontal marker, turn that on. And I'm going to set this for minus 15 dB. So we kind of like, or I kind of like to see my antennas where they're being used have a return loss a bit more than 15 dB. So I can see that kind of falls, in this area. And if I like, I can zoom in on this a little bit. I can click on this section and it'll take me right to an area where I can change. I'm going to change this to 5 dB per division, which magnifies this a little bit. I can go back to vertical and do a min search, and it's found the lowest point to be 21 dB return loss. And if I like, I can change this from return loss to VSWR. And so now I see the sweep as VSWR. Again, I can change that scale factor. I'll change that to a top line of 5. So now I'm seeing the VSWR is 1.2 to 1 at 882.352 megahertz. So let's take a look at distance to fault. Let's see how long this cable is on my mobile antenna. So I'm going to add a tab here. I'm going to add distance to fault. And I'm going to come into the configure screen here. And I'm going to select a cable type of RG58A. This gives me a pre-configured velocity factor and a loss per 100 feet at 500 megahertz. And I'm going to again choose 460 data points, change this to return loss and plot in feet. And I'm going to set my stop distance to 50 foot. And let's just take a look at that. So I'm going to add a marker, tell it to go to the peak. So I can see this cable length is 12.31 feet. And the return loss at that point is minus 5.5 dB. And it looks pretty good in between. With this sweep also, I could change that from return loss to VSWR, but it's more magnified if looking at it as return loss. Yeah, meters is also an option to look for the distance in meters. So let's do something here. I'm going to add a length of cable to this. So we use my markers now. Now my total length is 15.8 feet. And if I move my marker back to this peak, that's showing me it's around 3.5 feet. I can hit peak search to get right on that. 3.59 feet. So that's the length of cable that I added. And this is the connection point right here. So let's add another marker. And I'll move marker 2 to that total length. And now let's look at a marker table. So the marker table shows me 3.6 foot is there's a connection, and the total length now is 15.83 feet. If I go back to the marker menu and if I choose marker 1, I'm going to change this marker mode from normal to delta. So it's set a marker at the set that as a 0 distance. Now as I move it, it shows me that distance is 12.19 feet from where I enabled the delta to where I moved the marker to. So from the cable I added to the end is 12.19 feet. Now to document that, I'll just hit the camera, do a quick save. So I saved that screen. And that's all there is to testing an antenna.